Alright, so in this video we're going to go over some of the classwork examples on this handout. So what's actually a better idea is hopefully you've had a chance to work these out ahead of time, and then you're just here to just kind of check your work and to see how they were done. So if you haven't done them already, I encourage you to press pause first, come back to this video later, and then come and check your answers. I think that would be the best thing to do. Alright, so here is the solutions to these problems. Alright, so first for this problem, we were told, recalling class, that we want, when we're choosing a U substitution, we always try to choose the inner part of a composition. So here we're going to go ahead and choose U to be 4 minus y cubed. Alright, now computing du, we get that du will be negative 3y squared dy. And recall what we want to see is that on the outside of the substitution, so if this is u, this then is f, so now we're looking at just the outer part of the composition, this part out here. And we want to see du being a multiple, or exactly that sometimes, but we see that du is a multiple of what's on the outside of the substitution, or the composition, I should say. So that's good. So now, to make it look exactly like that, we're going to go ahead and multiply both sides by negative 1/3. So we get negative 1/3 du is equal to y squared dy. Okay, so now our substitution is going to be, we have the integral, we're going to replace this with u, so we get u to the 2/3. And then y squared dy, that's going to be negative 1/3 du, so we're going to take the negative 1/3, place it outside, du. And now we integrate this with respect to u. So finding the antiderivative of u to the 2/3, we get, adding 1 to that, we're going to get 5/3, and then dividing by 5/3 gives us 3/5 as the coefficient, plus c. The 3's are going to cancel, so we get negative 1/5, and then replacing u with 4 minus y cubed, we get negative 1/5 times 4 minus y cubed to the 5/3 plus c. Alright. The next problem, we are going to, once again, we see the composition here, so we're going to attempt to use u to be 2 plus x. So du is going to equal dx. Alright, now we notice here that du is dx, but there's an extra x squared on the outside. So do you remember when in class we said that if du doesn't have enough x's, or if it has too many x's, then there was a certain strategy that we would have to use for substitution. So think about that for a moment, or review your notes. Okay, so now what happens in that case is usually you're going to have to come back up to u here and try to rewrite u in a way so that we can get this. Well, we see that if we solve this for x, we get that x is equal to u minus 2, which would imply that x squared then would be equal to u minus 2 squared. And that's it. So now we can replace x squared with u minus 2 squared, and we can replace 2 plus x with u, and du with dx. So this integral becomes, replacing x squared, we get u minus 2 squared, and then here we get square root of u. Oops, forgot my integral. And then dx is du. And then now what we're going to do is we're going to multiply this out. So we get u squared minus 4u plus 4 times u to the half du. And multiplying the u to the 1/2 through, we get integral of u to the 5/2 minus 4u to the 3/2 plus 4u to the 1/2. And then finding the antiderivative of that, we get the u to the 5/2, that becomes, adding 1 there, we get u to the 7/2 divided by 7/2, it becomes 2/7, so 2/7 u to the 7/2 minus, here we're going to get 5/2, so it's going to be 4 times 2/5 u to the 5/2 plus, and then here we're going to have 4 times u to the 1/2. If we add 1 to that, we get 3/2, so it's 2/3 u to the 3/2 plus c. And then simplifying and replacing the u's, we get 2/7 u was 2 plus x, or x plus 2, to the 7/2 minus 8/5 times x plus 2 to the 5/2, and then plus 8/3 x plus 2 to the 3/2, and then plus c. And that would be the answer to number 2. All right. On this problem, the idea is noticing that we are on a symmetric interval. So recall in the notes that if we're on a symmetric interval, and especially if it's kind of a weird one where it doesn't seem like any of the strategy we've done in class, like, you know, basic integration or u substitution, there's no u substitution here that's going to work, right? Even if I try to let u equal x, then dx will, du will be dx, and that's not going to help me because I have this sine function here. So maybe what we try to do is we try to see if symmetric interval, see if this is an even or odd function. So if I call this f of x, right, and remember the test for even odd is you substitute in negative x and see what happens. So if I substitute negative x in here, I get sine of negative x over 1 plus negative x squared. Because sine is an odd function, the sine of negative x will be negative sine x. And of course, negative x squared is just x squared. And so notice we get the negative of f of x. Okay, so what we get here is negative sine x over 1 plus x squared, and so that's going to be negative of f of x. And if that's equal to negative f of x, that means that f is odd. So this is an odd function, and recall that if we're integrating an odd function over a symmetric interval, that the definite integral is going to equal 0. So we're done. All right. On this problem, let's see, we have x e to the negative x. So we're going to go ahead and, so here's the composition here with e composed of negative x squared. So we're going to let u equal let u equal negative x squared. Du is going to be negative 2x dx. And then good news, on the outside we see x dx, so du is a multiple of that. So we can go ahead and multiply both sides by negative 1/2. So negative 1/2 du is x dx. Now apply our substitution. Now we do have to be a little bit careful here. So recall that when we have a definite integral with u substitution, when we do a u substitution, we have to replace our limits of integration with u values, right? So here they're x values, but when we do u substitution, now they need to be u values. So first, I'm going to go ahead and leave the limits off for a second, and I'm going to go ahead and do my substitution. So here we said that this was u, so that becomes e to the u. X dx was negative 1/2 du, so I'm going to take the negative 1/2 out in front, du here, and now I'm going to replace my u. So to replace u, if u is equal to, not u, I mean it will be that, but not that yet. If x is equal to 0, then u is going to be equal to, and recall that we're just using this definition, right? If u is equal to negative x squared, so if x is equal to 0, we just substitute 0 in for x here, and so that we get negative of 0 squared, which is 0. If x is equal to 1 for the upper limit, then u is going to be negative of 1 squared, so that's going to be negative 1. Okay, so now we can replace those limits. So the 0 corresponds to u still being 0. The x equals 1 corresponds to u equal to negative 1. And here we have this. Now, once again, you don't have to do this, but if you are more comfortable with having the smaller value on the bottom, remember we can flip this and just switch this sign here, right? Well, we need to put a negative on the outside, but that negative will make this a positive. So if we do that, then we get negative 1 to 0 of e to the u du. And now this is going to be 1/2 of e to the u from negative 1 to 0, right? And that's going to be equal to 1/2 e to the 0 minus 1/2 e to the negative 1. So that's going to be simply e to the 0 is 1, so we get 1/2 minus e to the negative 1 is 1 over e, so 1 over 2e. And just leave it like that as an exact value. All right, so on this last one, we're going to go ahead and choose u to be, this time, we can choose it to be 1 plus cosine squared x. Now, remember, this kind of looks like the one that we did in lecture, but this one's slightly different. If I choose u to be 1 plus cosine squared x, then du is going to be equal to, this goes to 0. The derivative of this is going to be 2 cosine x, and the derivative of cosine x is negative sine x, so we get negative sine x dx. Now, you might get stuck here and think, oh, now what do I do because I have this extra cosine and I don't have a cosine out here. But the difference between this problem and the one that we did in class in lecture is, in lecture it was just sine x here, but here we have sine 2x. So we can actually apply the if we look a little bit closer, we see that this is actually the double angle formula, right, for sine. So this is really negative sine 2x. So we actually do have that du is on the outside here, right? If we want to think of this as 1 over 1 plus cosine squared x, and then sine 2x dx, that this portion is right here now, right? And so that now our substitution, I can just move the negative over like that, and now substitute. So we end up with this equaling the integral. I can replace this with u, so that's 1 over u. Sine 2x dx, that's going to be equal to negative du, so I can put the negative on the outside, du here. And of course the integral of 1 over u is ln of u, so we get negative ln of absolute u, replace the u, and we get this, right, replace u. But what we can also do as well is we can leave the absolute value bars, it's not going to hurt at all. But we can actually also just get rid of them because 1 plus cosine squared x is positive. It's always positive, never negative, so there's no need for the absolute value here. So we can go ahead and remove them so that we get this. Alright, so that is how you solve all the examples in the classwork with U substitution. If you have any questions about this, any of these examples, feel free to ask me during class, during break or after class, or during office hours. Alright, that'll be it.